because that's not going to be part of the recording. Okay, so next up, I would like to introduce Cheng-Yung Huang, and his talk is FORMOSAT-7 COSMIC-2 Mission Status and Future Operation.
Good morning, everyone. I'm Cheng-Yung Huang, and I will present the FORMOSAT COSMIC-2 mission status and our future operations. This slide is contributed by the TASA and NOAA and UCA and the Air Force. And this mission is a partnership. This is a cooperation missions, Taiwan and the US. And this is a contract by the AIT and TACOS. NOAA is the AIT designated representative, and TASA is the designated TACOS designated representative. And this is the 5 years missions and launched on June 25th and 2019, but launched by the SpaceX Falcon Heavies. And this is the satellite constellation distributed in 6 evenly space orbit planes to provide the uniform equatorial coverages. And we could see we could see figures.
You can also point at the monitor.
Okay, the middle figures shows the pace and the orbital. Show the orbitals planes about for. Okay. This is show the pace of the satellites and distributed even is along the equators and provided the uniform distributed out profiles. And we use the 10 ground stations for downlink support. Taiwan's ground stations for command and uplink the command to the satellites. And Darwin is the backup ground stations for command and uplink. And the other ground station are provided by the US side. 4 is the Mark 4. 4 is the from the Mark 4B, and 4 is the KSAT satellites, KSAT ground stations. And the TASA, the FORMOSAT has 3 instruments provided by the US Space Force. The primary instrument is tri-G radio occultations. And the other tools is ion velocity meters and the radio frequency beacons. And this the FORMOSAT-7 provided 5,500 daily radio occultation for weather forecastings, and provided 4,000 daily ionosphere total electron contents check for the space weather monitoring. And we use the 10 ground stations, 1 orbit is 100 minutes. So we will schedule 2 or 4 times to downlink the data. So we can shorten the data lessons to within the 30 minutes. And here shows the major post-launch program milestones. The satellites launched on the June 2019, and we just celebrating the 5 years birthdays this years, and we will continue to operate the satellites, try to extend the lifetime as longer as possible. And the milestone, this is some data released here. And on the March 20. May 2021, we upload the beta TGI softwares to increase the natural atmosphere our profiles. And then the June 2020, the ground station Tahiti join our teams to downlink the data, so we could shorten the data latency, media data latency within 30 minutes. And in recent years, we had to face the increase of the solar activities. So we had to do three times satellite maneuverment to maintain the satellite attitudes. And this year's August, we uploaded the TGS 4.5.1 software to satellites, and these versions could receive the Galileo signals. So, and now the UCAR are validating the data. So we might have very good news very soon. And this year we also had released the new ionosphere products, specifying the precious essence and the location of installations. And we released the two operations in March 2023 and February 2024. Here shows the satellite orbit altitudes. The parking orbit is the 720 kilometers, and the mission altitude is 520 to 550 kilometers. During the first 19 months, we deployed the satellites using the different precision rates between 550 kilometers and 720 kilometers. The difference is about 0.55 degree per day. And we take 108 days to separate the satellites to the other orbital planes. So we take 19 months to separate the satellites. And the rate of orbital decay rate start increasing noticeably since 2020s. The decrease rate before the 2020s, the decrease rate is just about 2 kilometers per year. And after the 2020s, the decrease rate reached to 50 kilometers per year. So we had performed three maneuvers for satellite altitude maintenance, and we could see the solar activities. The black curve shows the F10.7 solar radiation flux increase recent years, and the red curve shows the neutral density calculated by the MSI models. And so after the 2020s, with the orbital decay very quickly. And here shows the solar radiation flux and the AP index forecasted by NOAA. And this is our satellite operation plans during the 2024 and to the 27th June. TASA will maintain the altitude of satellites between 440 to 450 kilometers, or at higher altitudes. And for current plans, 2 or 3 racings will be required before the June 2027, taking 2 or 3 kilo propellants. The remaining propellants will be 3.5 to 5 kilometers. The remaining propellants is enough for the satellite constellation adjustment and the conjunction avoidance. The next racing may be scheduled in the June to February next year. And here shows our plans. And for the considering the satellite deorbit after 5 years of the satellite dysfunctions, we could not raising the satellite too high. So here, so I just show some case. We maintain the satellite above 400, about 540 kilometers, or we raised to higher to 560 kilometers or higher, 570 kilometers. And the 50 percentile is the best prediction by NOAA. So here I show the 15 percentile prediction and the 75 percentile predictions. And we will try to maintain, we will require 2 or 3 racing before the June 2027. And here shows the remaining propellants mass for the orbital maintenance. And okay, and the satellites, if we do not any actions after the 2027, the satellites will enter the Earth around the 2035 years. And so maybe if we had enough propellants, we will raise the satellites after the 2027. And here show the landforms we provided the data. The left websites provide the same products as the CDEC provide, and like the low data, atmosphere data. And the TACC had built up some the friendly interface for the general users. And the right platform is our space weather office, and provide the daily space weather overviews, space weather observation, and space weather monitoring, and space weather forecasting. And we also started to provide the new data, Triton data from this May 2024, and we welcome you to use our data and provide your experiments to us, and so we could improve our data providing. And here's the Taiwan meteorological satellites, and the red squares mark the now operating the satellites, FORMOSAT-7 and the Triton satellites, and the yellow squares are marked the highlights we will launch, and with the GNSSR and the other equipment. And we will combine the GNSSR and the GNSSR for our future missions. This is the schedule our satellite missions, the FORMOSAT-8 and the FORMOSAT-9. The FORMOSAT-8, we had 2 satellites. We had the GNSSR and RO and the FORMOSAT-9, and they will launch the 2027 and 2029 and 2030. And these are the some figures about our future missions. And here shows the products. Our satellites will receive at 1 and 5, and the Galileo E1 and the E5 signals. And estimated we will provide our profile. Because the GNSSR and the RO is the second payloads. The main payload is the stars. So the RO and the R maybe not the 100% duties. And now we are actually I and my colleagues, next speakers, are working to improve our hardware or our schedules to try to increase the more profiles. Okay. And then the right panels show the distribution of FORMOSAT-9X, and the upper panel shows the global distributions, and is the sun-synchronized orbit. So the local time will focus on the 11:30 a.m. and PM. And here shows the our numbers versus the azimuth angles and versus the latitudes. So here's my conclusions. That we had completed the 5 years missions designed life on the 2027 July 25. Collected more than 9.6 and 6.9 million profiles for atmosphere and ionospheres. Had great achievements on weather, space weather forecast, and scientific applications. And the TASA will continue to our best to maintain the operation for FORMOSAT-7 to provide more data for atmosphere and ionospheres, and also outline the next visions on our missions in future. Thank you.
Thank you. We have time for one short question. Okay, thank you. Appreciate it. Okay, next talk is Young-Fu Tsai, and will be giving a status update for Triton GNSS-R mission.
Thank you. And morning, everyone. I will give you the status update for the near the Triton GNSS reflectometry mission for this presentation. And I'm Yong-Fu Tsai, and actually I'm working in charge of the Triton GNSS reflectometry the receiver development, and Dr. Ye Wenhao is in charge of the Triton GNSS mission data the data analysis, and Tom Lin Chen Zhonglin is program director of the Triton mission satellite mission. And as you know, the FORMOSAT-7 constellation is a demonstration the GNSS are all for weather precision. And Triton actually was once one of the version of FORMOSAT-7 COSMIC-2 constellation satellite. But now it changed to its main mission is conduct the reflectometry mission for the GNSS remote sensing application. So last year, October 9th, Triton was launched from the Guyana with the Vega launch vehicle. And two major missions for the Triton satellite. One is process GNSS reflect the signal and retrieve the data to be the wind speed for the weather prediction. And the other mission for the Triton satellite is to demonstrate Taiwan build component and technology, and to boost up the Taiwanese space induction. For the second part, we want to do some technology demonstration. So in the Triton satellite, we have several technology demonstration, and these are shows in the following table. And actually, they already from I think it's already past all this validation process. And for the GNSS reflectometry payload development approach, actually we cooperate with the Taiwan's domestic organization or the company, such as E-Tree for all the GNSS high-gain cannot development, also have development all the LNA by the E-Tree. And we also cooperate with the university such as National Cheng-Yung University to develop the develop map the algorithm and to develop the GNSS with 他们去mission payload the prototype. So for the early orbit operation, the status of the Triton satellite, actually the sun pointing was achieved less than 2 hours after the satellite separation, and the Triton satellite into the normal mode in 2 days. And we switch on the GNSS payload on the 3rd day after launch. And we also demonstration our self-development the H2O2 the thruster, and we conduct some calibration burn in the 2nd week of after launch. And several because some the single event upset we occurred some ARO the automatic reconfiguration order, but just a few event occur on the Triton satellite. And for the GNSS payload, the data calibration plan, and we after one month operation, we make the payload operation parameter, and for the level 1 calibration through the about 2 months operation, we confirm the level 1 calibration method. And for the wind speed retriever, after the 4 to 5 months after level 1A the calibration. And this slide shows all the GNSS retrieval the process. Actually, we will download the raw data from the satellite, and we'll do the L1A the correlation and the L1B level 1A and level 1B for the calibration. And we will conduct the level 2 the retrieval for the roughness and then U10 to get the roughness of the wind, ocean surface and the U10 the wind speed product from level 2 retrieval. And for all the data download from the ground station, will archive this data archive this data in our central user in for the future processing. And for the data calibration method, actually this portion is most done by the Dr. Ye. So I just brief some for the level 1 the calibration, we use this method, use a parameter, 2-dimension parameter to make the coefficient of the C noise of the DDM noise. And when we get the noise of the DDM parameter, we can use several method. We use roughly right now we use 100 days to get the calibration the parameter from for the Triton data. And once we confirm the parameter, we use this method for the level 1A the DDM data calibration. And for the Triton, we will get the MBIS data, because once we get the calibrate the DDM, the P, so we can get the MBIS from the effective scaling area. And we in the Triton data, because we have a higher resolution of the DDM, so we can use this method to get the MBIS. But for the signals, for the signals data, they use WGS 84 and plus the I think it's the I forgot the wind height, the model. They use the model to get the effective scaling area. And for this method, we use this method to verify the MBRS data verify the MBIS. So once we get the MBIS, confirm the MBIS, we can retrieve the Triton's wind speed. And for the GNF, we use because the left hand side, I think you will maybe you will underestimate the wind speed. For the right hand side, they may overestimate the wind speed. So we use this method to combine. Right now, the weighting of these two methods, the weighting is equals 0.5 and 0.5 to combine to average the result. So from this method, we get the coefficient of the GNF model, and then we will use this coefficient to retrieve our wind speed product. And actually, from the last October, the Triton was launched, and we will conduct the wind speed retrieval result from the December of the 2023. So the Lumen square is about 3.0 meter per second. And this the following slide shows each month we will conduct the wind speed retrieval result from the 2023 December until June and July. And so far, the conclusion for the Triton's data, the retrieval, the Lumen square error of the retrieval wind service wind speed compared with the ECMWF is around 2.7 meter per second. And because in the beginning of the GNSS operation, we find something. Sometimes it will occur the single event offset to cause the DDM data anomaly. So in that time we make the decision to reboot the GNSS the receiver every day in the beginning of the first operation. So before the March of 2024. So this strategy is conduct. We power cycle GNSS payload before every day before the March of the 2024. So we get the roughly was retrieval Lumen square result. And after that, because we developed some method to detect when the single only the single event offset occur in the GNSS receiver, we just power cycle the GNSS. So after the March of the 2024, we implement this method to prevent the GNSS power cycle every day, so we can get the better result from after the March of 2024. And right now, in about the data analysis based on the Triton product, the version 1.0. Right now, we are preparing the Triton based data product version 2.0. It will release no later than the mid of the next year, 2025. And so we will DDM collaboration with MBRCS, then review the GMF model, and meanwhile the balance method to combine the two GMF wind speed. As I mentioned the previous slide, right now the balance the method is weighting is equal, and in the version 2.0 will even minimize the balance minimize balance this 2 month GNFS And we also try to use the resample numerical run to retrieve the high speed wind speed result from to build the GNFF model. And right now the Triton data was released on everyone can register the account and to download the Triton data. So that's my presentation. Thank you.
Thank you very much. We have time for a couple questions.
I have one. I thought someone said it has RO data as well. Is that not true or true?
Actually, Triton only has reflectometry data, no RO. And but as Dr. Huang said, we are planning the ROR payload in the following the FORMOSAT-9. Yeah.
Yeah, I have a question. What do you think the maximum wind speed?
Pardon?
What do you, in your opinion, what is the maximum wind speed you can retrieve from GNSSR?
So far, is from the result is I think it's around less than 15 meter per second.
Yeah. Well, and I mean, optimistically in your slide, you said you were trying to develop something to improve the maximum right there, high wind speed.
Yeah.
Are you going to try to push that limit a little higher? And what do you
because
think is feasible? Because the curve flattens.
yeah.
So there's
And we try to cooperate with the Professor Yang with their I don't and ensemble natural run to get the high speed result. But right now we still in progress, so I don't know where's the limitation or how quick can we process. Yeah.
Thank you. Yeah, no problem. We can. Oh, yeah.
One more question, please.
So just a quick question. Is this data publicly available now?
You can register the account from this website. So, okay.
Okay, thank you.
All the data was storage in our CWB. You can register account.
Okay, thank you very much. Our next talk will be Billy Galata, an architecture study for a U.S. government radio occultation backbone.
Okay, so as you probably have noticed, what Natalie just said, the title of my talk is, and the title you see up here is a little bit different. When I submitted the abstract originally, we had only completed the initial backbone study. It's now expanded into some more large-scale architecture studies.